In today's video, we're going to take what we learned yesterday about derivatives of exponential and logarithmic functions, and we're going to apply them to some application problems. And then we're going to do a little work reviewing domain and seeing how this applies to these problems. So for number one, the question we're being asked is at what point on the graph of the function y equals 2 to the t minus 3 does the tangent line have a slope of 21? So the first thing I'm thinking is I need to know something about the tangent line and that slope. I know what I need to do there is take the derivative of my function with respect to t. And I know that's going to give me the slope of the tangent. So I have an exponential function, so I know the derivative of 2 to the t is going to be 2 to the t times the natural log of 2. And since I want to know where that has a slope of 21, really what I want to figure out is where is that equal to 21. And so now I have an equation that I can solve to find the value of t. So I'm going to switch over just to my black pen here. So I need to isolate t. So the first thing I'm going to do is divide by the natural log of 2. So I have 2 to the t equals 21 over the natural log of 2. Now, I need to get my variable out of the exponent. So to undo that exponential function, I'm going to take the natural log of both sides. So the natural log of 2 to the t equals the natural log of 21 over the natural log of 2. And I'm going to take this up here. Now, since I have the natural log, I know I can move my exponent down to the front. So what I have is t times the natural log of 2 is equal to the natural log of 21 over the natural log of 2. And so now to isolate t, all I'm going to do is divide both sides by the natural log of 2. Which looks messy, but we're just going to use our calculator to find that value. And so we have to be careful with our parentheses and how we enter this. I have the natural log of 21 divided by the natural log of 2. And so when I do that, I get approximately 4.921. So now, it's asking for what point on the graph does the tangent line have this slope. So what we just found is our x-coordinate of that point. Now, to get the y-coordinate, I'm going to take this value and I'm going to plug it into y. And so when I do that, again, that's just going back to your calculator. And I get a y value of approximately 27.295. So that's going to tell me the point at which that function has a tangent line with a slope of 21. Okay, so now for the next problem, here's what we have. So it says a line with slope m passes through the origin and is tangent to the graph of y equals the natural log of x. And so what we have to find is the value of m, or in other words, the value of that slope. So here's what I know. I know that the slope is m. But I also know it's tangent to the graph of y equals natural log of x. So that slope has to be equal to the derivative of y with respect to x, which I know is 1 over x. So I know that m is equal to 1 over x. I don't know its value yet, but at least I have some relationship to work with. The next thing I know about my line, it has a slope m, and it passes through the origin. So I know my point then is going to be 0, 0. So I can use the information that I have so far to write an equation in point-slope form. So I know that y minus 0 equals 1 over x times x minus 0. And with a little simplification, what I really know now is that y equals 1. So I still don't have the value of m, but I know that y equals 1. So now I can go back to my equation, y equals the natural log of x, and I can take this value 1, and now I can say that 1 is equal to the natural log of x. Now, I know natural log has a base e, so I'm going to convert this to an exponential, and what I know is e to the 1 is equal to x. So in other words, x is equal to e. Now I can take this x value and plug it into my slope, and so what I really know is m equals 1 over e. And that's the answer to our problem. Okay, so for the last piece of this, we're just going to talk a little bit about domain, just basic domain of certain types of functions. Again, the notation is a little off here, so we're going to change all these u's to x's. That one's okay. Here we've got an u. Okay, so for domain of logarithmic functions, I know that my x for a logarithmic function has to be greater than 0. For rational functions, we know that our q of x, our denominator, cannot be equal to 0. And if I have an even root function here, I know that x has to be greater than or equal to 0. So here's the type of question that we might see. So for number 3, it says f of x is the natural log of x minus 3. It wants us to find f prime of x and state the domain of f prime. So finding f prime of x is easy. This is natural log, so I just have 1 over x minus 3. And since the derivative of my inside function is just 1, that's my derivative. So now, I know that the domain, if I'm just looking at f prime of x, I know here that the x cannot be equal to 3. So it's tempting to say that our domain is all reals except for x equals 3. However, here's where we have to consider the domain of f of x as well. So if we look at the domain of f of x, we know now that for f of x, x minus 3 has to be greater than 0, which means x is greater than 3. This domain is much more restrictive than x not equal to 3, so we need to take the more restrictive domain. So what is important to emphasize here is that when we're talking about the domain, we have to consider not just the domain of the derivative, but also the domain of the original function itself. So in this case, the domain of f prime of x is x greater than 3. And that's it for today.